This is the Unit 5 review. Number 1 says draw the graph f of x equals the square root of x, and it asks what the domain and range are. So the square root starts at 0, 0, and the square root of 1 is 1. The square root of 2 is some decimal, square root of 3 is some decimal. The next number y value comes when x is 4. So the square root of 4 is 2. And then after that, a square root of 9 is 3. So if you're not sure, of course, you can check in the calculator. Looks something like this. X starts at 0, and I increased along my x-axis. Y starts at 0, and I increased along my y-axis. So my domain and range are both related to 0. So x is greater than or equal to 0, and y is greater than or equal to 0. I fixed my graph. It's supposed to be at 4, 2. I had it at 5, 2. So the points I used are 0, 0, 1, 1, 4, 2, and 9, 3. Number 2 says draw the graph f of x equals the square root of x minus 4 minus 1. And list all the transformations, find the domain and range, and find the x and y intercepts. So I'll put it in y1, square root of x minus 4. And remember to arrow out, it has the blinking arrow. So you're going to press the right arrow key. And now you can type outside the square root minus 1. So I'm going to graph it. Okay, so now I need to find points. It looks like it started around 4. I should have started at 4, negative 1. And then I have 2 more points after that I could plot. And you can see that x is increasing and y is increasing. So that's good for my domain and range. So the domain x is greater than or equal to 4. The range y is greater than or equal to negative 1. And I want points like 4, negative 1, 5, 0, and 8, 1. So that's what my graph looks like. So the transformations from my parent, the parent, which is number 1 was our parent function, starts at 0, 0. So my graph went to the right 4 and down 1. And I can see if there's any stretching or compressing. From the parent function, the first 2 points, I went over 1, up 1. And on my graph here, I went over 1, up 1. So there's no stretching, no compressing, since they changed by the same amount. So the x and y intercepts, this one, it doesn't even touch the y-axis at all. So there's no y-intercept. That is my x-intercept, 5, 0. Across the x-axis at 5, 0. Number 3 is going to be a little bit more tricky, since I have -2 on the outside. I'm going to go straight to my graph and see what it looks like. Remember to arrow out +3. So my graph started over here at -5, 3, and it's facing down now, like it's curving down. So I'm gonna go up. -5, 3 is my starting point. You can see that my y values are decreasing, they're getting negative. So from 3, it went down to 1, and then it started into the negatives. So my range is y is less than 3. My x values are still increasing. So x is greater than or equal to -5 for my domain. And from the table, I want to use points like -5, 3, -4, 1, -1, 1, or -1, -1 rather, and 4, 3, or 4, -3. That's about it. So that's enough points anyway. -5, +3, -4, 1, -1, -1, and 4, -3. And so now you can see there's a difference. When I go to my next point, I had to go down to right 1. So there's a stretching happening between these 2 points. Like on number 2, there was a difference of right 1, up 1 between the 2 points, 4, -1, and 5, 0. Here, there's a difference of 2 and 1. So there's a stretching. So it's a vertical stretch by 2. The fact that it's upside down now, that's a reflection. And that's across the x-axis. And then from the origin, my first point moved left 5, up 3. So there was 4 transformations happening on number 3. And I do indeed have an x and a y intercept. So my x-intercept is when my y value is 0. My y-intercept is when my x value is 0. The y-intercept is always the easiest to find. You can look in the table for it. So here x is 0, so my y-intercept is roughly -1.47. My x-intercept, I'm going to have the calculator calculate that, or you can do it by hand. If you wanted to do it by hand, you're going to set your equation equal to 0. But on the test, you have enough solving questions, you're going to be kind of pressed for time. So if you want to do it on the calculator and go back to graph, you're going to press the second key and trace, and you want to calculate this 0. So it says left bound, so you need to be on the left side of where it crossed. It crossed right about here. So my cursor is on the left side. I'm going to press enter. Right bound is over here. I'm going to press enter. And so it's trapping my x-intercept in between these two vertical lines. I'm going to press enter. So my 0, my x-intercept is negative 2.750. So number 4 says find the inverse. Finding the inverse, we made a table. And we wrote down the operations starting with x. So what operations are you performing to get to your y value? So it's kind of, if you're putting a value in for x, like 1 or 500, what are you doing following PEMDAS to get to your y value by hand, if you're calculating it by hand? If you're following PEMDAS, you're going to look inside the parentheses first. Our square root is kind of acting as our parenthesis, or set of our parentheses. So inside, we're subtracting 4. Then our square root is its own operation. We took the square root. Then on the outside, we added 3. So on the inverse, that's where you start at the last operation and undo that. So the opposite of plus 3 is minus 3. The opposite of square root is square. And the opposite of subtract 4 is add 4. So I'm going to use this right side and go in order to write my inverse function. So when I write my inverse, the first thing I'm going to do is write x, and I'm going to follow my steps. So from x, I subtracted 3, I squared, and I added 4. So comparing the function and its inverse, you can kind of see a pattern going on. The plus 3, the opposite is inside. Plus 3 was on the outside, so now the opposite's on the inside. And subtract 4, the opposite is on the outside. So looking at number 4, I'm going to try to just write out the equation for number 5. On the inside is negative 1, so the outside should be plus 1, and the outside here is plus 7, so the inside of the inverse should be minus 7. And under the opposite of square is square root, so it should be x minus 7 plus 1. So I'm going to make my table and see if I did that right. So the first thing I did here was subtract 1. Then I squared. And then I added 7. So on the inverse, I subtracted 7. I took the square root, and I added 1. So here I write x, I subtract 7, I took the square root, and then I added 1. So yeah. that is my inverse.